Hello everyone, welcome to Module 5, Session 2, Predictive Analytics with Big Data. Our speaker today is Joe, so if you have any comments or questions for him, please use the chat or the Q&A box. With that said, I will hand it over to our speaker. Joe, the session.
Thank you, Franklin. So hi everyone, hi again. Good morning, good afternoon, or good evening. So this is the second session of Big Data. Thank you again for joining us today. My name is Joe Fai Chow, or you can just call me Joe. I'm a senior data science evangelist at H2O. But if you have joined the first sessions or watched the replay, know that I'm best in taking selfies with people around the world. But today, let me try to focus on machine learning. So today I want to show you two interesting real-world use cases of big data. And my hope is that these sessions can give you a better idea of how to extract values from data with machine learning platforms like H2O. Okay, here is our journey so far. I hope that you have joined us since module 1. But if you haven't, if you missed any of the previous module, you can go back to our training center and you can watch the replay. If you have more questions about this module after the live session today, there will be a study group and Ask Me Anything forum over the weekend. Next week, my colleague Ben will talk about responsible AI, so please join us again around the same time. Okay, here's the agenda for today. I'll do a quick recap of session 1, just in case you missed it. Then I'll go through two use cases with you in more details. The first one is a very common financial use case about credit risk scoring. I will use a mortgage loan data set for this example. The second one is one of my favorite projects so far. It's about a real-world Moneyball applications that are built with a team of experts back in 2018. And after the use case, I'll wrap up with a quick summary and what's next. Part 1, a quick recap of the big data and technologies. So we talk about what is big data. Big data is everywhere in our daily life. It can be a photo or video you post on social media. It could be a Google search. It could be your passport scan at the airport. It could be your online shopping history. And it could be the cat photos that you post online and share online. So yeah, we are generating a lot of data every single day. We also talk about how to describe big data. So I use a common 5 V's approach. So this is a simple approach to talk about big data. So to describe big data, how big it is, what's the volume, variety, and so on. And there's certainly some value from big data. So we want to find out how to extract value from big data. And I talk about some of the tools, some of the technologies that we can use today to extract value. So Hadoop and Spark are the two frameworks that I talk about. So we can use these tools to manage the data in a distributed fashion. So this is very important because we need to deal with huge amount of data, and the data is growing every single day. So we need to have some tools for that. So I also mentioned about machine learning with big data. So again, we need something that is scalable, that we can use it in distributed fashions. So H2O, the machine learning platform, is one of the tools that we can use to do scalable machine learning with big data. And finally, we talk about some use case. So you can see that many use cases in different sector. Today, the first example is about credit risk scoring. So it's a really common use case in the financial service sector. So yeah, the key takeaway message from session 1 is that we have technologies now to extract value from data. So now this is the time to show you how to do it. Okay, part 2. So the first demo, credit risk scoring. I'm going to use a mortgage loan data set, and then I try to use H2O, AutoML to analyze data and create a model that can give us some predictions on new data set. So this is a publicly available data set. It's from Freddie Mac. This is historical data, loan data from the past many years, and you can download the full data set from their website. You can see the link there. I'm only using a subset of the data. It's about 1 million records just for this demo. But you know, when you are ready to try, get your hands dirty, you can try the full data set from Freddie Mac. So there are many features in for example, the credit score for each of the loan requests, the applications. Is it first-time home buyer? What's the first payment date? What is the insurance percentage of the mortgage? What's the type of the product, the type of the mortgage? What's the type of the properties? So these are the things that we can use to describe and to train a model on, to look at what's the impact of these features on the target. The target itself is called delinquent. So which means if you have a true value for delinquent, that means there was delayed with that loan, which is bad. If you have false, that actually means those are good customers, so they actually had no delay in repayment. So we want to train the model with these features and target, and try to figure out if there's some new customer coming in, they apply for mortgage. We can use the same features and try to estimate the probability of the loan repayment, whether there's a risk or not. So let's go back to Machine Learning 101 or Machine Learning Basics. In this simple diagram, I want to show you how we're going to frame this problem as a machine learning problem. You know that we have features, we call it X, and then we have target. This is the known target from the historical data, we call it Y. And what we want to do is to use machine learning or supervised learning, in this case, to learn from the relationship between X and Y and create an approximate functions between X and Y, so that we can reuse this feature, we can reuse this function and apply it to a new data set to make some predictions on new data. So this is a way to get some insight from data. Let's look at how we can do it with the mortgage loan data. This is how we should think about the problem when we try to think any kind of business problem into machine learning problems. So we want to look at what kind of features are there are available to the users. So in this case, we have credit score, the first payment date, etc., etc. So we want to use that and to associate target from data. So in this case, true or false. So that's it's a binary classification this time. So we'll use machine learning to learn that relationship between features and target, and use that as a functions to look at new data sets in the future. So you expect the prediction coming back in one number between 0 and 1. So if the prediction is closer to 0, that means that is likely to be false. So that is a good indication of there will be no delay in payment. False is like good customers. On the other hand, if you have a number closer to 1, that means there could be a problem with the loan application. So that is the point you have to talk to the domain expert and say, okay, there may be some problem with this loan application, and you may want to spend more time looking at it in details. This is how we get some insights from data. And putting it into today's context, because I want to also show you the AutoML functions in H2. So I will use H2 AutoML to do the supervised learning part of this process, because this is quite useful for any users, from beginners to expert. The reason is that sometimes it's difficult to figure out which supervised learning algorithm or what settings are the best for a new data set. So if we can have some tools to automate that kind of training, tuning, and stacking process, that will save us a lot of time and more bandwidth to look at other problems around the machine learning process. So if you want to find out more about AutoML features in H2O, I would suggest that you have a look at my colleague Evan Adele's video on YouTube. So she is the mastermind behind AutoML. So he's the video link to her talk at the last H2O World about the AutoML function in H2O. So basically, it's a really cool features to automate some of the most time-consuming tasks in machine learning process. So training different kind of algorithms in H2O, tuning the hyperparameters, and then try to stack them together and see if we can get a higher quality model compared to the individual models. So let me show you what it's like with the web interface. So in this course, AI Foundation course, we focus on just the surface of it. So we try to use the web interface, so it's very easy to use. So in a minute, so you will see that you can actually use the web interface and train lots of machine learning models with just a few clicks. But when we get to the next stage, when we get to the ML Foundation course, after this AI foundation course, there will be more hands-on example in Python now. So I hope that this will at least get you interested in machine learning. To more detailed examples in programming languages. And this is what you expect from running AutoML. So AutoML try to bring a lot of different models, the different algorithms available in H2O, and try to use different settings for different algorithms as well. So the idea is to try it and see which one is going to perform the best on such data set, on same data set. Because if you want to train different problems on different new data sets, you may not have the time to do this manually. So the benefit here is to save the time to do some of the from some of the really time-consuming and repetitive tasks for machine learning. So this will get you to the really good starting point. And if you have more time on this problem, you can actually look at the details of this model and try to get the settings from those parameters and try to fine tune it to create your own, the best model from your own. But this is like a really good starting point when you face a new challenge. Okay, so we're almost there to the live demo. But before that, I just want to tell you what I'm going to do, and then I will do it, and then tell you what I've done again. So hopefully this will reinforce the idea of AutoML with this data. And there's also a link here. This is mainly for myself because I may need to copy and paste this. So this is a link to the demo data set. So you can also try that after this live sessions on our aquarium or your own machines. So these are the steps that I'm going to do. So I will collect to the actual cluster that I set it up on the cloud. It's a quite powerful machine because there are 96 CPU cores. So I will show you some statistics from the clusters, and I will try to import the log dataset from internet using the link to the dataset, and I will explore the data a little bit so you can look at different kind of features and what's the distribution of the value for different features. That can be quite useful before you do any training of the models. And I will split the data set into two, one for training. So it could be 75% for training and 25% for testing. So you can kind of imagine that the 25% could be like a new data set from new customers. Just imagine that. And then I will train and compare different models using AutoML. So I will show you how we can just use a few clicks and get a lot of model in a really short time. It could be just 1 minute. And finally, when we have the leaderboard from AutoML, we can pick the best model and use it to make predictions, or you can use any model from this as well. And finally, we'll look at the prediction and see how we can use them to make some decisions on the loan approval. So that's the path. And here we go. Okay, so let me make it full screen. Okay, so this is like the first page that you will see when you connect to H2O cluster using the web interface before H2O flow. So we can see it. If not, just type in the chat box. So what I want you to show you first is the panel here on the right hand side. So you can see there's a real example flows here. If you click on that, then you find more examples. So these are different examples that I will show today. But when you have time, you can go through each of them. For example, you can click on the GBM example, and you can see, this is just like a notebook, our notebook, but you can run it. You can just go and run everything, and then we'll show you some results. But today I want to show you something from scratch. So let me just create a new one. So first, I want to show you two things about the system itself, the cluster itself. So I want to show you the cluster status. So let me minimize this. So this is on AWS. So I have a beefy, really powerful server at 96 core. And I can also show you what we call the water meter. So this is like the CPU usage graph here. For now, you don't see anything because we're not running anything yet. So you can see just the blue bars here, 96 of them. So in a minute, when I start using AutoML to train models, you will see a lot of green bars going up together. And then you can tell that we are using H2O to distribute the workload across all the CPU resource. And that's how we actually can scale up the process, because when you're ready to scale it up, you can just add more resource like CPU and memory to the same cluster, and then you have a more powerful machine. So it's scalable horizontally. So let's go back to, okay. So first step for the machine learning is all about data. So again, I need to import data first. So I should have the URL in that. Yeah. So this is what I want to do. So I want to import this CSV file from internet. So look at it, define it, and I can now import it. So it's not in the memory yet, because we need to do a few more steps before you take it from internet to the actual cluster. So first we need to look at the features. So when I click on parse, so it actually show you a list of column first. So you can now change the type of the column. For example, the first one credit score, I know that is numeric. They are all just number, so that's okay. And there will be some categorical value here, like this one. The third one is called the first time home buyer fact. So it's like what we call elem is the in Java. That's called that's the categorical value in Java. We call it elem. So you can see that it's either no or yes. So that's N or Y. So that's also okay. And so on. You can also look at the other features, make sure that you're happy with that when you work on your data set. And I can go on to the next page, make sure that I have the target here, the delinquent here. This is my target that I want to use it for the machine learning model. So again, this is elem. So that's the categorical value with false or true. That's it. I'm happy with this. So I can now click on parse, and I will now actually load it into the memory of the actual cluster. So what I want to do next is just to have a look of the data set. So we're not trying to train any model yet. It's useful to just have a look at what is in this data. So you will see there are some simple statistics. So we have 1 million rows. This is 1 million samples from this subset of the Predimat known data. And there are 27 columns. One of them is the target. So the 26 features and one target. And you can see this is when it is compressed, it's not that big. It's only 45 megabytes in memory. But no, this is good enough. No, this is not really big in today's standard, but it's good enough for a demo for today. Okay, so now we have this data in the cluster. I can look at different features. For example, I can click on credit score, and it will show me quickly, because it's numerical value, so it will show me a quick histogram about the distribution of different credit score in the data set. You can, when you have time, you can click on every one of them and you have a look. I just want to show you one more, which is the target. So delinquent. So and you can see that most of them, they are false. So most of them, they're good customer with no problem with the payment. And there are some loans that became problematic. So we need to use this model here to train the model and try to figure out what's wrong with future customers. So that's the goal of this exercise. Okay. So now we have the data in the cluster, but we don't want to use all of them to train the model, because that is just memorizing everything in the model. So we try to do something very simple. So we want to do a split frame, which is splitting the data set into two parts. So the first part could be 75% or 80%. It's up to you how you want to do it. So, but 75% is a good start. So I'll call it train. And the second one with test. I can also assign random seed here. So when you do it again with the same number of the same seed, you expect the same kind of split from data. So I created it. And then you can see two new frames here. I can click on train, and you can now see, okay, this is the about 75% of 1 million, so 750,000. And then they have the same number of column and then the same kind of features. So this is the one that I will use to build my model. And the same for the test set is about 25% of total. Okay, so now we have the suite. So I want to show you how quickly we can do it with AutoML. So let's go to either the build model or one AutoML. I can do it here. And there are a few things that you need to provide. So it's not automatic on in all areas. So first of all, you need to tell H2 I need to look at the target delinquent here because it cannot guess the target for you. You have to tell H2O this is the one I want to predict. And then I'll leave all the other settings for you to play with after the live sessions. Yeah, you can also say put a name here. I will say this is module 5 demo, and I will go on to look at to have some columns that you don't want to include. Could be the ID column, could be other things that you don't want to use. You can click here, but I want to use everything here for now. And then you can also look at the number of course validation flows. So I will use 3 here just for a quick demo, but use 5 or use more if you want to. And then you can also exclude any of the algorithm that you don't want to use. For example, if you think deep learning is not good, so you can exclude that. But in this case, I will just include everything here and let it try, give me some result. Again, I want to use the same seed number. So this is again trying to match the result. Again, if I want this again, you should give me the same result. And let me limit the time here. So I'm saying to H2O AutoML, I want to spend 1 minute. So 60 seconds for this experiment. Give me the best you can do in 60 seconds and just show me all the moves. So that's what I'm trying to do here, 60 seconds for this exercise here. And now you can click build models. So what's happening now is that actually we're trying to do a lot of model here. Oops. Let me go back and see what's happening. Okay, let me try again. Try again with this. So train, and then we'll go to and then set a seed here. So 3 and 60 seconds. Let me try again. Maybe it's the name of the so let me try again. Okay, now it's running. So what I wanted to show you is the water meter again. If you remember that I talked about the water meter, so it's now using all the CPU cores evenly. So we distribute the workload to them evenly. So without any kind of manual configuration. So this is quite useful because you can keep the same kind of code here. This is like a notebook for H2O, but imagine when you work on Python and now you have the pipeline ready, then you can just run the same code. Just a little bit different to a more powerful cluster, but you can reuse the same code when you want to scale it up. So what we're trying to do is to test lots of different models, so we can also monitor it live. So whenever we have built a model, it will create new models on a leaderboard. So we are trying to look at, so in this case, automatically it shows the accuracy for the leaderboard. So we will see more and more models coming up. So when the time is up, up after 1 minute, it will stop and it will use all this model built in that 1 minute to build 2 more stack ensembles. One is using all the models, the other one using the best of family. Okay. So in this case, you can see that now we tried to look at different kind of models, and then we can see that some of them are doing better. We also see a stack ensemble here, and what we can now do is to use any of the model here to predict on the new data set. For example, we can use top model here, GPM here, or we could be using the stack ensemble here. So let me try to use one of them here. And I can now have the option to predict. So this is like using the model here, we trained it to predict on the test data set. So let's do that. Test data set here. And I can just click predict. And it's done. So we have the prediction here. What I can do next is to combine it with the original frame so we can see the actual record next to the predictions. I'll do that. And I look at the frame. Okay. And I want to look at the actual data itself. So this is the point that we can start using the model and the predictions to make some decisions. So if you remember, each of the record here is one long application. So we have the actual features of different node. And we also have the prediction here with the percentage. So this is saying that the first sample here, the first application here, we're saying that there's 98.57% that is going to be false. So it's going to be a good one. So we don't have to worry about it too much. And if you scroll down a little bit, so we first define the 24 record here, then we see that there's a 68% of this being true. So that means we should look at this with more record here, because there's a higher probability that this will become a problematic node. And so on. Let me just find maybe one more feature. Say again, this one here, you see that he got even higher percentage or probability of this being a bad node. So we got a 73.8% percentage. So this time, maybe you can use the number here to prioritize your resource as well. So you want to look at the most problematic nodes and so on. It depends on how much manpower you have to go through all this node. But this machine learning model here is giving us a really good assistant, saying that we don't have to look at everything manually. We can focus on the most highly problematic ones, and then we can use the time better, because we don't have to spend everything all the time to look at every single record. So that is a really quick demo of the AutoML. So let me go back to slide. Yeah. Okay. So hope that you had a feeling of how this can work with data. So you have the tools here, H2O, and then you've got AutoML here. You can prepare your data set. And once you import data, you can use it to accelerate the knowledge discovery. So you can have some insights from the data very quickly. And you can also scale it up. So you can just add more and more machines to that. If you have bigger data, you can just scale it up your more powerful machines to get it done in a timely manner. So this is what we try to do. We try to make it easier for everyone to extract value from data. We want to democratize AI, and that's enough marketing for today. Let's move on to the next demo. So part 3. So this is also my favorite part. It's about the making of a real-world Moneyball application. The goal is to identify some undervalued players, so undervalued baseball player with machine learning. This is important because you want to find them, sign them up before your competitors do. So I hope I won't get too excited when I talk about this. If I do, if I raise my voice too much, I apologize in advance. Okay, so if you can raise your hands using the chat box, please do. So if you have heard about this movie or this book, please let me know. This is a book by Michael Lewis, and then there was a movie back in 2011. It is a real problem. It's a real multi-million-dollar business problem. There's competitions for teams to find the most underrated players, of course, before other teams notice them. And not only for baseball, it also applies to all the organizations in sports. So let's look at this business problem in more detail. So what is the real business problem for the baseball team, for a baseball player? So back in the day, so when they have forecasts, like forecast for the player's performance, this one was an example from ESPN website. They usually had just one single point prediction for next season. So that's a really short-term forecast. But if you put yourself into the shoes of the baseball players and the managers, they usually want to consider contracts for longer term, maybe 3 to 5 years or even longer. In that case, the teams here, when they negotiate the contract with the players, they really want to think about the long-term performance of the player. You want to look at more than 1 year, just in case that if you only have 1 year of good performance, it may not be worth the worth money of the transfer. So they need to have something in place, some system to predict the long-term performance for 3 to 5 years. So that's the problem, the real problem for them. So why do I do this? So there was a time I was working with my friend David Kearns from IBM. So we want to do some interesting demo. So we don't want to just look at credit scoring. We want to do a bit more interesting demos. So we chose baseball as one of the topics. We have other topics in mind, but we want to use baseball as an interesting demo. So David discussed this idea internally with IBM, and he found that one of the partners, Agility, they had an expert, they had a baseball expert. We didn't know much about Ari. We only found out a lot more about him after a few Google's search. But we know that we can form a team with him, and then we can leverage his knowledge and his own baseball data. And then little did we know that when we did our homework, we found that he is the character in Moneyball. So there was a character in Moneyball called Peter Brand. He's the brain of the whole the team. So, but the movie was based on the life of Ari. It's a long story because the real person who worked for Oakland A's is called Paul Poster, but Paul didn't want to work with the filmmakers. And so the filmmakers interview Ari instead and use his life story, use his, all the information from Ari to create a fictional character, Peter Brand. So that's what you saw in the movie. And then this is like the story behind our team. So we do have a real Moneyball expert in the team. This is way before I Google Ari. Okay, just like any other machine learning project, we need to start with data. So we look at what is available. So first we look at what is publicly available. So we got a Lemon database. It's quite famous. You can also download it from the website. But it's aggregated, meaning that for each player, each year, you only have one single record. So then we try to find a much bigger, much richer database. And luckily we have Ari because he has been collecting data for many years, and some in great details as well. For example, he got data for pitch by pitch data, which means that for each of the pitch they did over the years, he know about the velocity of the ball, position of the ball from start to the end, what's the type of the pitch. A lot of things that I don't really understand still because I'm not a baseball expert. He got all details considered and collected in this rich database, which is proprietary and I cannot share with you today. But this is a really cool database, and we want to use that to build the model. And then we need to frame the problems. So what are we trying to predict? So we want to predict the player performance in the future, and all these they are key performance indicator. They're all numerical value. So we want to use regression in this case. So frame the data set as a regression problems, so we can use the data to predict the player performance in numbers. So we are using the historical player performance data as features, and I use XGeo AutoML just as what I showed you earlier in the first demo to build different examples to predict different key performance indicators. So that's how I use XGeo with his data. So back to the machine learning 101. This is there are two approaches. When we look at this, there are two approaches because we want to compare a simple approach, which is the first one. We are using just the publicly available data from them. We're using the player age, the height, the weight, and some historical performance statistics as a features. There are about 300 of them in total, and then we are trying to predict. We're trying to predict the figures like home runs, what's the batting average, etc. So these are some of the key indicators when they try to look at the performance of baseball player, and then we have XGeo AutoML to learn the pattern. The second approach is quite similar. We're just adding a lot more data into it. So we again aggregate the data from Ari, so that create another 200 features. But these are a lot richer, a lot more detailed features that we can use to describe the performance over the years for each player. So again, we build a similar model, but we have a lot more data into it. So we have about 200 extra features from Ari and on top of the 300 from Lemon. So we build another model, and you get before you see the result, you know that this is going to be a better model than the first approach. So let me fast forward to the result. Actually, I have a link to the full-length talk, so full version of Moneyball talk back in 2018. So I will have it in the resource page later. But let me just fast forward to the actual end result, this model. So what we're looking at is one of the key indicators. We call the whip, we call walks and hits per inning pitched. So this is a key value or a key measurement for pitcher. So imagine that when you're pitching the ball, you don't want the batter to hit your ball or to walk away better in this case. We want to have some figure that's lower and lower and lower over the year. So what we're saying here is two different models. So you can see green and orange. But let me explain the strategy first. So we're trying to split the data in like a time series fashion. So we have the first few years, so from 2011 to 2015. So we use that as training, and then we hold out 2 years data points for the validations, and then we got trying to predict the next 3 years. So it was the reference time is 2018 to 2020. So we use that for RE to look at the performance of different players in the future. And then you can see that now for the approach 2, the second approach with RE database, we got a much more believable, or as RE said, more closer to his expectations model than just using the data set, the green one. So we are going with the second approach. We can use this model to predict different players. That is one of the breakthrough back in the day, because if you remember, we only had like a single point predictions from different websites, and they are only about next seasons. But now we're going to look at next 3 seasons, and that gives RE the advantage of looking at the long-term performance of the players that he was interested to shine. So if you can tell from the performance of the previous graph is about this guy, Christian. He is the MVP. He's the one of the best player as a pitcher. And that's why we can see that the performance of him is getting better and better, because lower is better. And he actually won the World Series with Boston Red Sox. If you're a baseball fan, you should know about this history. So there's no surprise that he had a really good performance forecast in a couple of years, because he's still one of the best guys in the league. But for RE, he wasn't looking at the star players. He was looking at for some undervalued players, so may not have that kind of stellar performance, but they have really, really good value that's not overlooked by the other players. So you want to do that with the predictions from H2O. So that became the next challenge for me, because I cannot just give all the numbers. I cannot just give all the predictions from the model to RE. There must be a reason for each predictions that I need to explain to him, so for him to understand what's going on, for him to validate the model, for him to trust the models. So I chose one of the framework available at the time. It's called LIME. LIME, the full term is the Local Interpretable Model Agnostic Explanations. It's one of the framework that we can use to create some approximate reasoning of the complex result. So it's also model agnostic, meaning that you don't need to worry about whether it's an ensemble, it's a single model, like a random forest or single GBM. You don't have to worry about what kind of model you're using. You just need to make sure that you can have the predictions from those model, and use that. You can create some approximate reasonings of different attributes to the outcome. So what we are trying to so here is different features in a data set and how they contribute to the final outcome. So we're looking at my chart, one of the another player here. So we have a prediction about 0.28, and how do we come to that number? So we are using this bar here to show the contribution of different features to the final number. And because this number to me, they didn't really make sense, because I didn't know much about baseball at the time, but they did make sense to RE, because he can kind of match that with his own expectation. So with this feature, that has a positive or negative impact on the outcome. So we can look at this and kind of gain the trust of the model. So he looked at a few of them from time to time, and then finally he trusts the model that I built for him. And that's how we move on to the next stage, because he still had a long list of players to go through, and I cannot just create a graph for all the players, individually or manually. So what I did, I created what we call a Shiny app. It's a simple application, but it's quite useful for him to check the performance of different players, for the players that he wanted to sign. So this is the moment I want to go to the next demo. So I need to okay, and I'll show you how this is actually working. Okay, so I hope that you can see my screen. So this is the app I built for him. So that we did for the IBM Think conference back in the day that we could travel. So the app here is quite basic. So there are two results tab. So the first one is the result for all the picture, and second one is the result for all the batter. So he was looking for picture. So this is like the first person here is Cristal, the star player, and then what he need to do is just go through. Okay, I want to look at another player, look at the performance over time. Are they going down? Are they going up? Is it good or not? And then he can also look at the explanation for different features, different predictions, and try to use his domain expert knowledge to validate the model. So after an hour or two, he was using the app for real, for about an hour or two, and he found the player. He found the player that he won, because for legal reason I cannot reveal the name of his team, the player that they signed. But this is what we did with the app. So we use the app to find a player. How we look at the explanation, look at the performance predictions in the future, and then he found the one that he really want to sign. So let me go back to presentation. So that you can see that is on a day he was Ari was using the app to find a player. So I wasn't sure that he was using the app for real. So I thought it was just a joke. He just trying to play with the app, but he actually found the player he want, and he recommended to the team. The team negotiated a contract with the player, and within a few days they finalized the contract and they signed him up just 2 weeks before the regular season. So it's a multi-year contract, so it's good for him. And this is my project that I'm really proud of over the years, because I like this is the one idea of using data from a sport event, from sports teams, and try to get some insight for a domain expert like Ari to sign up a player, and that's quite cool. Okay. So to sum up, I guess I have showed 2 demos about how to get from business problems to actionable insights. So if you have the data, if you have people who know how to frame the data into a business or machine learning problems, you can use different tools to extract value, extract some insight from data, and that certainly can give you some competitive edge in the market. And that's why we want to introduce to you the role of all these tools and all this possibility with different use cases. So I hope that you enjoy this 2 demo. So let me just wrap up quickly with a summary and what's next. Okay, so for session 1, I discussed the big data. So what is big data? What are the characteristics of big data? We use a 5V system to describe it. And we also have technologies to store, to process, and to extract value from data. And there are many use cases in the world. So I show you 2 of them today. The first one, the financial one, is about credit risk scoring. So I use the mortgage data for a demo. The second one is my own project. We use baseball data or baseball players' performance data to identify the undervalued players. So for the sports team. So these are the two use cases that I hope that you can relate to some of your daily problems, and I hope that when you're ready to try out the Xio platform, whether it's Java's AI or Xio 3, you can also try it with your own data set and see if we can get some new insights from the data. So very quickly, what's next? So I'm sure that if you have followed the previous module, you know that we will have study group and ask me anything over the weekend. So if you have more questions, if I couldn't answer everything today, you can also try again for doing the study group and ask me anything forum. And then next week we have module 6, responsible AI. Attend this module. Responsible AI is one of the most important topics nowadays because AI is getting more and more popular and more and more in our daily life. You should know about the other side of the AI, which is how can we be responsible when we use AI in our decision-making process. And don't forget about the quizzes. So I've prepared the quizzes for you for these sessions and last sessions. They are not that difficult, so you can find all the answer from my slide, I promise. But do complete them before deadline, and then you will get the badges. And lastly, for the resource here, I got a few more links for you this time. So if you really want to get your hands on the software, just go back to Learning Center. You will see the Java's AI tutorials and the Xio 3 tutorials, and then you can use the datasets that come with the lab. So we have prepared everything for you. The environment is really useful for getting your hands on. You don't have to install anything. Everything is ready for you. Just use a web browser and get into it. And you can also look at the other webinar, and then we have the AI glossary that we keep on improving from time to time. If you're interested in the full version of the Moneyball talk, which talk a lot more about the actual details of how we frame the problem and how we use the data, you can go to you can try this link, and you can also look at more use cases from our website. Again, the link here. And finally, if you want to check out my life before the lockdown, so how I travel everywhere and took selfie with different local communities, you can just Google this hashtag, so around the world with Xio AI. Okay, so that is it for me. So let me have a sip of water, and I'll look at your questions. Okay, so let me go for the questions. First one, so what are the data processing functions available in Xio 3 before the building step? Oh, yeah. So what we have, if you use the Python, the R API, you can use Xio to do some basic functions. For example, you can join a table, you can split the data set, you can merge it in different ways, you can do some kind of basic data processing. So how do you take the mean or do a summary of different columns? So you can do some of those basic steps with Xio scale. If you think that you need actually more advanced functions, then sometimes you can also combine the pipeline with other libraries. So for example, in R, you can use data log table, or actually we have both in data table in both R and Python now. So you can do that for more advanced data wrangling exercise before you fit the data into Xio. You can also use just a built-in function from Xio. It really depends on what you feel comfortable with the data merging step. Okay. So the next question is about the Shiny app can be created in Xio. Of course, we can do it in Q, but I haven't done it yet. There's because one of the reasons is that I don't have the data from Android. This is what we had back in 2018. So I cannot have a copy of this data. It's proprietary. But we can certainly do something in Q, something that you can demonstrate how can you use the results from machine learning models and present it in a nice way that helping people make decisions on different business problems. So that's what we're trying to do with Q, try to make use of the machine learning power from Java's AI and Xio 3 models, and we use the result presented in a really nice way to help other people make decisions. So technology behind the Shiny app is just a library. So I use Art I use the H2O with out, I use the line package in out, and then I use the signing package. It's our package. So everything is in the our ecosystem. If you go to the link, so if you go to the link of my Moneyball talk, I got the link to my GitHub repository, so you can find some of the code there. So I couldn't share all of it because of the data, but I share some of the basic part of the Moneyball application. It's quite useful because not only for the Moneyball, you can use this for your analysis. So I recommend that if you have time to learn it, you can use Shiny, or then you can also use our Q system. So it is like there are many different tools available today to create your own application. So next question is, how do we use H2O Flow? So if you go to let me just go. Share a few. Oops. So if you go to our documentation site, so you can see this is the main site of all the help here. If you go to H2O, and there is the quick user guide here. So if you go there, and then you see that now this is how you find all the information about H2O. If I go to download action, so this is how like more basic way to start H2O. So you need to have Java. You need to download the H2O in Java. So after you unzip that, there is a jar here. There's a jar that you can call, and then when you call it, that becomes a service on the machines that you just run this jar, and then you can go to that IP address of that server. So usually it's opened in the port 45321. And that's how you can access to the full interface. So it's free, it's open source. So you only need to download the latest version or any version before to zip it, unzip it, and then you have the jar to use H2O. And that's how you do it without out. If you want to use it in R and Python, you can look at the instruction here to see how you can install the H2O module in the different environment. Okay, I can paste that link here. Let me just copy that. Let me just put it here. 1 minute. So if I send it to everyone, so this is the link. This is the link that you see in the chat box. It's the link to download H2O and run it from the command line. Okay. So the other question is about the H2O kill feature. I'm not too sure about that yet. So if I have the latest answer, I'll get back to you. So I don't have the latest answer yet, so I'm not sure. Okay, so that's a long question. So let me just read through it. So using Elm as a part, so it could instead of modeled, don't be used under as Boolean. Okay, so Elm here, Elm in the flow interface that you saw could be multi-class, could be different labels in one single column. So it is not only about binary, so it's not only about Boolean. So it could be like cat, dogs, and mouse. So that is what we do with H2O. So that could be a multi-categorical value in one single column. Oh, you want to look at the Moneyball link? Okay, so let me go to here, and let me this. Okay, and then you will find more link from this this stack. Okay, I think I've answered all the questions. Unless you have any other questions, just let me know. So I do hope that you enjoy the module part so far. I try to prepare as best as I can to show you 2 demos, and there are lots of things that we can do with AI. But the most important thing is get your hands dirty. I guess it's just try it. You may fail first your stack, and then you'll see how can we combine different technologies together, like the one that I use for the Shiny app. So I wasn't planning to do any Shiny app at all, but then I saw the opportunities to make it into an application. So I just did, and it was it's like you have to try different things first, and then when the time comes, you know how to combine them and use them together to build something beautiful. Okay, so I see there's no other questions. I want to thank every one of you again, and I hope that you will join us again next week for the Responsible AI. Thank you.